Today we're going to talk about strategies to ace the MCAT Organic Chemistry section. Many students struggled with organic chemistry in college and assume that they need to know all of the organic chemistry they learned in undergrad in order to succeed on the MCAT. In addition, many students who have taken practice exams find themselves getting tripped up by the questions that seem to require long mechanisms or memorization of specific details to answer them correctly. If that sounds like you, you're not alone, and we're here to help. I'm Vikram Shah, MCAT expert and 528 MCAT scorer. In this video, we'll go over where you can expect to see organic chemistry on the MCAT, in addition to study strategies you can use to attack complex problems. My goal for this video is for you to walk away understanding which topics are on the exam, how to approach organic chemistry problems you encounter on the exam, and how to study your mistakes so you can achieve your best score on the MCAT. Let's get started. How much organic chemistry is actually on the MCAT? First, a little MCAT OChem overview. When you take the MCAT, the exam is broken down into 4 sections. The first section tests you on chemistry and physics with 59 questions. 44 of these questions are passage-based, while 15 are standalone questions. Organic chemistry falls into this chemistry and physics, or chem phys section. Even though you spent 1 or 2 semesters studying organic chemistry in undergrad, you will not likely see as much organic chemistry as you might expect on the actual exam. So let's break it down by the numbers. According to the test makers at the AAMC, OChem will be about 15% of your chemistry physics section, give or take 5%. So that means between 10 to 20% of your MCAT chemistry physics section will focus on OChem. In other words, your exam will likely contain between 6 and 12 questions discussing organic chemistry. Since chemistry physics is only one of 4 sections, organic chemistry plays an even smaller role in your overall score. You may be surprised to find out that organic chemistry will actually be only about 3 to 5% of your entire exam, or 6 to 12 questions out of 230 total questions. Why do we mention this? If you're studying on a time crunch, you should prioritize higher yield material over memorizing complicated organic chemistry reactions. Here, we will teach you how to focus on the high-yield, big-picture material in order to maximize both your score and your time. First, however, we will cover a general overview of the topics that they will test you about on test day, and then we will cover study strategies you can use to answer difficult questions. Students often wonder what organic chemistry topics will show up, so we've broken it down for you here into a few general topics. The way the AAMC frames organic chemistry in their MCAT content guide is based on functional groups. If we think way back to organic chemistry, a functional group is an important piece of a molecule that is responsible for the molecule's chemistry. In other words, the functional group tells us how the molecule is going to behave. Since functional groups are the centerpiece of how the AAMC talks about organic chemistry on the test, we will introduce the topics you need to know as individual functional groups and then dive into study strategies you can use to maximize your score on MCAT organic chemistry questions. The topics are: Topic 1, aldehydes and ketones, which includes carbohydrates. Topic 2, alcohols. Topic 3, carboxylic acids. Topic 4, acid derivatives, which include lipids. Topic 5, phenols. Topic 6, cyclic aromatic compounds. In addition to these functional groups, you should also be familiar with experimental techniques, such as the following. Topic 7, separations and purifications. Topic 8, spectroscopy. Now, let's look at study strategies you can use to maximize your score. MCAT Organic Chemistry strategy number 1 is simple. Know the structure of the functional groups like the back of your hand. If someone asks you to draw an aldehyde, it should be second nature. You should have the same level of memorization of organic chemistry functional groups as you do over amino acids. So you should know what the following functional groups look like at a bare minimum: carbonyl, aldehyde, ketone, acetal, hemiacetal, imine, enamine, aldol, alcohol, carboxylic acid, amide, ester, anhydride, and phenol. If you know the structure, that will help you even more with MCAT Organic Chemistry strategy number 2. Know the properties of functional groups so that you can understand how they will react. Let's look at a commonly tested example, the carboxylic acid functional group. If you draw out the structure of a carboxylic acid, you will notice that there are important parts of the molecule that contribute to how it reacts with other molecules. For example, the oxygen double bonded to the central carbon has some interesting properties. What is more electronegative, oxygen or carbon? If you said oxygen, that is correct. Oxygen wants electrons a lot more than carbon. So the oxygen will pull on those electrons harder, causing it to have a partial negative charge. As a result, the carbon will then have a partial positive charge. Why is that important? It is important because this makes the carbon a reactive atom now. The carbon really wants electrons due to its partial positive charge, making it an electrophile, or something that likes electrons. And something with an extra pair of electrons, or a nucleophile, can now attack the carbon and engage in interesting chemistry. Understanding these properties for each functional group that we just mentioned will help you solve organic chemistry problems without having to remember specific and complicated organic chemistry reactions. Make sure to pay special attention to understanding the carbonyl functional group, which is any carbon double bonded to an oxygen, and the properties we just talked about, as the MCAT loves to test students on it. Now, let's look at MCAT Organic Chemistry strategy number 3. Understand experimental techniques commonly used in organic chemistry, such as separations, purifications, and spectroscopy. The MCAT will expect you to be familiar with these basic organic chemistry tools, and we'll walk through the basics of each one here. Before doing that, however, I want to remind you that anytime you miss an MCAT Organic Chemistry question while doing practice, be sure to go back and review that question, write down what you needed to know, and study it. And you shouldn't just do this for practice organic chemistry questions, you should do it for all practice questions that you take. Now, let's walk through separations and purifications. You will need to be familiar with extractions, distillation, and various forms of chromatography. What is the underlying goal for these different approaches? We want to separate two or more chemical compounds from one another, and we can use the different properties of the compounds to do this. For example, let's look at extractions. Think back to your organic chemistry lab when you separated aqueous and organic phases in a flask. Why did you do this? The goal is to separate your compound of interest from other compounds in the flask. If your compound was 2 benzene rings, would you expect it to be in the aqueous or organic layer? Remember, benzene is a 6-carbon ring with the double bonds. In chemistry, like dissolves like. The aqueous layer will dissolve molecules that are similar to water, meaning molecules that are polar or hydrophilic. The organic layer, on the other hand, will dissolve molecules that are nonpolar and hydrophobic. Benzene does not have any functional groups that would make it polar, and it is made up of only nonpolar CH bonds. Therefore, we would expect to find benzene in the organic layer. Since we know that our compound of interest is in the organic layer, all we have to do is collect the organic layer in order to have a pure compound. Next, distillation separates compounds based on their boiling point. In thinking back to general chemistry, boiling point is determined based on intermolecular forces. Molecules with weaker intermolecular forces will have lower boiling points. If we take another look at benzene and water, which most likely has a lower boiling point? Both molecules engage in van der Waals interactions, and benzene will have some hydrophobic interactions. Water, however, can engage in hydrogen bonding and dipole-dipole interactions. Therefore, benzene has weaker intermolecular forces and a lower boiling point. Distillation will separate these two compounds based on those different boiling points. Chromatography follows a very similar logic. We will use molecular interactions to separate compounds. Two common approaches are gas chromatography and liquid chromatography, but the principle behind both is the same. In chromatography, there are 2 phases: a stationary phase that doesn't move, and a mobile phase that passes through the stationary phase. The stationary and mobile phases have different chemical properties. For example, the stationary phase may be nonpolar, while the mobile phase is polar. Let's say a polar molecule was used as a sample. The molecule would likely travel more closely with the polar mobile phase, causing it to elute more quickly in gas chromatography, or run higher on a paper chromatography plate. Now that we've broadly looked at separations and purifications, let's move on to our final topic, spectroscopy. You should be familiar with both IR and NMR spectroscopy, though you likely won't have to know them at the same level of detail you did in undergraduate organic chemistry. IR spectroscopy is a spectroscopic technique that provides information about the functional groups present in a molecule. It is often used to measure the progress of a reaction in organic chemistry. The MCAT Organic Chemistry section will expect you to know 2 big peaks at a bare minimum. The first is a narrow peak at 1700 wave numbers that indicates the presence of a carbonyl group, while the second is a broad peak between 3100 and 37 wave numbers that indicates the presence of an OH group. Let's look at a practice question. A researcher performs an organic reaction in which a benzene with an alcohol substituent turns into a benzene with an aldehyde substituent. Which of the following peaks may appear for the product in IR spectroscopy? A. Broad, 3500 wave numbers. B. Sharp, 3500 wave numbers. C. Broad, 1700 wave numbers. Or D. Sharp, 1700 wave numbers. The question is asking for the product peak, so we want to know what would appear in a benzene with an aldehyde substituent. Thinking back to our functional groups, what does an aldehyde contain? If you said a carbonyl group, you are correct. Like I stated earlier, a carbonyl group will show itself as a narrow or sharp peak at 1700 wave numbers. So D is our correct answer for this question. Finally, MCAT Organic Chemistry may ask you questions about NMR spectroscopy, which is a technique used to gain insight into the chemical composition of a molecule. An NMR spectra is quite complex, but thankfully the MCAT will not ask you extremely complex questions about NMR. Instead, you should be familiar with benchmark numbers, similar to IR. Here are the numbers you should be familiar with, and each describes a shift you would see on the graph for a specific chemical bond. Hydrogens on sp3 carbons, 0 to 3 parts per million. Hydrogens on sp2 carbons, 4.6 to 6.0 parts per million. Hydrogens on sp carbons, 2 to 3 parts per million. Aldehyde hydrogens, 9 to 10 parts per million. Carboxylic acid hydrogens, 10.5 to 12 parts per million. And aromatic hydrogens, 6 to 8.5 parts per million. These are a brief introduction to the high-yield organic chemistry topics you will see on the MCAT. And be sure to study any additional OChem topics you see on official AAMC practice exams in order to succeed on the MCAT. By now, we have covered the general overview of MCAT Organic Chemistry, and you have a toolbox of study strategies to attack your practice problems and increase your MCAT chemistry physics score. If you found this video helpful, give it a thumbs up and subscribe so you don't miss out on new videos. And if you'd like to receive a free MCAT question of the day so you can get in every last bit of practice before test day, click the link in the description. Thanks for watching, and we'll see you next time.